All right, perfect. It's 9 a.m. So let's get started. Good morning, good afternoon, everyone. Welcome to the data streaming launch. We have a packed agenda today. Really excited about a lot of updates we want to cover with you today. So let's get started. So quick introductions. Joining me today is CJ Guo. He's the co-founder and CEO of Stream Native. Dustin Nest, technical trainer at Stream Native, and I'm a part of the product team here at Stream Native. So let's get started. So we have mainly three topics to cover today. We want to talk about Ursa, some announcements related to that. We want to talk about universal linking capability, which we're launching, and also go over a nice demo to walk you through all the capabilities of universal linking. So those are the three topics for today, and perhaps some Q&A at the end if there's some time left. So CJ, do you want to get us started from this?
Sure. Thanks, Kudan. So for people who might or might not know about kind of Ursa, Ursa is kind of our newest kind of a data streaming engine that we built to kind of address five major of the cost drivers of Kafka. That including like inter-zone data traffic, the data transfer, expensive disk-based replication, and typically Kafka couple both storage and compute together. So it will result in over-provisioning compute resources. And if you want to use Kafka together with Lakehouse, you also need using connectors, you would also need to send different copies to different systems. It might be Databricks, Snowflake, or many other kind of analytics system. By Ursa is designed in a ways to leverage Lakehouse as the native storage and adapted a lead list architecture. So by animating some of these major five cost drivers, we're able to kind of cut Kafka cost by like 95%. And we recently did a benchmark together with Databricks by looking into the Kafka Ursa cost and running a 5 GB per second workload comparing with Kafka, Rapanda, MSK. And if you can see in the next slides, the benchmark is actually showing that we are able to kind of run 5 GB Kafka workloads for just like $54 per hour. And if you're looking into this cost breakdown, you can see by leveraging Lakehouse as native storage, we are able to remove like 24% of inter-zone client server communication, and we're able to kind of remove about 71% of the cost coming from the inter-zone data replication. So that's kind of huge cost reduction. If you're running like a data intensive workloads, Ursa is going to be a perfect solution for you to sending tons of data through Ursa and forget about the cost at all. And because it's based on Lakehouse, the data is stored in Lakehouse tables. In order to kind of fully utilize the power of these Lakehouse tables, we recently, in the past few, I would say months, we have kind of working with different industry leaders to integrate natively with both Databricks, Snowflake catalogs. So if moving into the next slide, now Ursa is entirely natively like integrated with both Databricks Unity catalog if you're using Delta or Iceberg on Databricks. And we also natively integrate with Snowflake Open Catalog, which is through the Iceberg REST catalog specification. So if you are a Snowflake users, now you can have the option to write data into your like S3 bucket using Ursa engine. All the data will be kind of saved as Iceberg tables, and then you can connect your Snowflake Open Catalog with your S3 bucket. Then your Snowflake can query and process the data. And most exciting, in addition to Snowflake integrations, last week AWS S3 also released its own Iceberg REST catalog support. We were honored to be the first one of the data streaming engine integrate natively with AWS S3 tables. So you can also pick AWS S3 table buckets and streaming data directly into those buckets. And that will become an Iceberg table can be used and queried by other AWS analytic tools such as Asina. So with integration of all these three popular data catalog solutions, we are able to kind of easily expose the data through a broader lakehouse ecosystem. And so with all these cost saving and data catalog integration, I'm really excited to announce that Ursa is now GA on AWS BYOC for Kafka support. So moving into the next slide, you will see the Ursa, if you're using AWS BYOC, there's an option that is available for you to creating an Ursa cluster. And that cluster is fully support the Kafka protocol. You're able to kind of use it to cut your Kafka cost, and it's natively integrated with Databricks, Snowflake, and AWS S3 tables. Pick the right integration that you already use. And you can also scan the QR code to get started on Streamlit Cloud and give it a try. So with that being said, I'm going to hand back to Kudan. He's going to talk about another exciting kind of features we introduced to Stream Native.
Awesome. Thank you so much, CJ. This is great. Really exciting to hear about Ursa going GA. Awesome. So today we want to talk about one more announcement, and let me set some context for that. Let me talk a little bit about Kafka replication. There are many use cases for Kafka replication, but today we want to focus primarily on two. The very first one, the real-time data lakehouse. This is mainly about enabling existing Kafka deployments to kind of support broader set of use cases for AI and HTAP and others. So for that, typically what we would do is like, keep your existing Kafka deployment going, but at the same time, you want to replicate your data into an open format, something like Delta Lake or Iceberg, which is well understood by third-party tools, so they can easily, discover, query, and then analyze that data. Kafka migration is a very common, use case. This is really the scenario where any organization who wants to move away from a certain, Kafka deployment or a cluster to a data platform which broadly supports their needs, they're oftentimes in need of a automated tool which helps them with the migration, not just with the data, but everything around the data, which is schemas and all kinds of configurations. And speaking of the tools, there are so many tools out there which can help you actually with the Kafka migration. Tools like MirrorMaker, uReplicator are open source. I think, they've been around for some time now. Great job. A lot of people who've contributed to those tools. But actually, they come with a lot of limitations around offset management, schema replication, and other sort of capabilities which you'll need as you're planning your migration. Tools from Confluent, like replicator cluster linking, actually resolve most of those challenges. But they still come with a cost associated with networking, particularly because for certain scenarios or use cases, because of the way Confluence tools run, particularly with a single protocol on the internet, they can incur a lot of networking costs, right? So I want to actually talk a little bit about StreamNative's vision and what approach we take when we look into these challenges. We really focus on two particular aspects and principles as we are trying to solve different problems. Interoperability definitely is one. As we are for all the problems we solve, for the solutions we come up with, our typically aim is to offer that capability which can be broadly supported across different data streaming platforms like Pulsar or Kafka. So it's easier for customers to kind of make a choice between them. The second one, cost effectiveness, is obviously a very popular theme now in the brave new world where everyone's very cost conscious. So as we think about a solution to any of the problem, we definitely try to ensure that, cost does not become a concern for any organization to adopt that, whether you're running in a small SMB type of a scenario or a large enterprise running, an applications in scale. As you scale up your application, cost should not become a concern while you adopt a solution. And that's one thing we always try to ensure, right? So on that note, basically, I'm really excited to announce the public preview availability for universal linking. Universal linking is something which we announced back in Data Streaming Summit October last year. It was in private preview back then. And today we are happy to announce this is basically in public preview, which means that anyone can sign up for a Stream Native Cloud trial and go try this out themselves. So what is universal linking? Universal linking essentially is a built-in capability within Stream Native Cloud, a fully managed service, which allows you to replicate your data from your source Kafka cluster to Stream Native Cloud. Now, it basically takes care of a lot of those challenges which the most tools out there actually still have when it comes to migrating your Kafka workloads. Like UniLink takes care of giving you a flexible way to move your topics, your schemas, all sorts of configurations, supporting all kinds of things which you need to take care of while dealing with offsets. So it's really, that's what we call full fidelity replication. So you can really rely on this tool to kind of be able to replicate that. Also, the tool really offers you a lot of value when it comes to cutting down on your storage costs. And I'll talk a little bit about that very shortly. Just because of the way it's designed to kind of stream data into a headless data storage, that itself cuts down a lot of your storage costs. Also, it works with most, pretty much all of the Kafka compatible systems like Confluent, MSK, Redpanda, and others. You can connect to those systems from UniLink and be able to replicate the data. So I think, let me talk a little more about universal link and how this works. So in the beginning, I mentioned about two different use cases. The first one was real-time data lakehouse, and the second was really about migration. So let's talk a little bit about the real-time data lakehouse. So this is really a scenario where if you want to keep your existing Kafka deployment on, your source Kafka cluster on, and yet support a broader set of use cases for AI and others, you typically use universal linking to replicate the data as it is getting produced into your source cluster. The data comes into a headless data storage. It gets landed as a Ursa stream format, which is our own format. Data is compacted and then stored in open format like Delta Lake and Iceberg based on your choice, right? Now, the beauty about this approach is that your destination cluster, where you want to actually, move your data, that can consume data like from your producers and consumers can consume data from the Ursa streams. But as you're planning to expand your core deployment to a broader set of use cases for AI, your external tools, which CJ was talking about, this is really the integration which he spoke about for Ursa natively that can integrate with any tool which can understand these open formats really well so that they can easily discover, query, and analyze the data stored in Delta and Iceberg formats. So it's pretty powerful where you have a single store which is serving two different types of consumers, one from your regular, Stream Native cluster, and one is from the third-party tools for either data science teams or data engineering teams or other projects who want to consume this data in an open format. So pretty powerful. I think, definitely give this a try. It's in public preview. I'll quickly highlight one thing before handing over to Dustin for an exciting demo. See, this is really what I was talking about when it comes to the vision which we have, which aligns based on two different principles, and cost effectiveness is being one of them. As we were thinking about solving this, I think leveraging object storage for replication definitely gave us a lot of benefits, and we pass on those benefits to our customers. And this is how object storage services like S3 definitely offer us a lot of value when it comes to kind of replicating data instead of moving data directly from the source Kafka cluster to a destination, Stream Native cluster, right? Also, the Ursa stream format is something as we load the data into the headless storage, this is actually being used as a serving layer for all our stateless brokers, which can serve the data to all the producers and consumers. So I think it's a very different way of, approaching, data replication, and we are really excited about that. Okay. So that's a quick update on UniLink. It's in public preview. Give that a try. We'll chat more about that at the end. But let me now hand it over to Dustin so he can walk you through an exciting demo. Dustin, over to you.
Sure. Thanks, Kundan. So we're going to try and go through so you can see the full process. We're going to use the Ursa cluster. We're going to use the Open Catalog backend, and we're going to demo UniLink. Hopefully everything goes okay. My internet went out for about a minute, a little bit earlier while Kundan was talking. So hopefully it's stable for a good 15 minutes or so here. Let me go ahead and share my screen. Everything look good, Kundan? My screen?
Yes, looks good. I can see the Confluent Cloud. Yeah.
Okay. Actually, and then if I move that, can you see the background as well, the ones behind?
The IDE, yes.
Perfect. Okay, so we're actually going to start by discussing a little bit about UniLink. So what we're going to do is I'm going to start publishing some data into a Confluent cluster, because that would basically be your source cluster, what we're going to call a legacy cluster. And we want to eventually use UniLink to move that data over into an Ursa cluster and then be able to see that data inside of Snowflake, S3 tables, or Databricks. And then we actually want to migrate your actual application over to the Ursa cluster as well, so you can get that 95% cost savings. So I'm just showing you this here. This is where we're kind of starting, is with this cluster. If I go into cluster settings, just to keep everything clean here, this is going to be our Bootstrap server that we're going to use. So I'm going to hop over into IntelliJ and show you that I'm going to start publishing messages into this cluster. So here's my IDE here. We're actually going to be, the goal is to get the existing data into Snowflake, as well as all of the new data that you're publishing with your application. So here's that Bootstrap server here that I'm going to be using. And then I'm going to be publishing to a Kafka topic called Kafka 5. Let me go ahead and just start up that producer. Again, this is pointing into our legacy cluster. Let's hope my internet is stable enough to get my IDE running too, because I'm publishing locally. Here we go. Okay, so here we're publishing the data. Again, this has nothing to do with Ursa yet. And then I'm going to be consuming the data over here on my source cluster as well. And then my consumer group here, I'm just calling Kafka 5. That's going to be important because we're going to try and move this application over as seamlessly as possible. So here we're up to message 24, and you can see the consumer here is running on the source cluster. So the first thing I would do then at this point is I would like to spin up an Ursa cluster. We obviously don't have time to do all of the spinning up. So let me head on over into Stream Native Cloud and show you that I actually have 2 clusters up and running right now. This first one, we're going to be using Snow I1 or Snow C1. This is the cluster that is already configured to use Snowflake as the open catalog, Snowflake open catalog. So any data that shows up on this cluster should automatically be available for us inside of Snowflake. Obviously, I haven't published any data to this, but the first thing we want to do is get our existing applications data into this cluster with UniLink. And as CJ and Kundan mentioned, that's going to be using S3 as a backend as object storage. So you don't have to incur all of the network charges to move what could be massive amounts of data into this cluster. So let me first show you that configuration here. So you can see here, I'm using, here's my Snowflake endpoint for the open catalog, which is based on Polaris. I'm going to be using Warehouse 2. That's just the warehouse inside of open catalog. So we're going to be heading on over there in just a little bit. And this is that bucket that is the backend for this cluster inside of S3. If I go to tenants in the public tenant default namespace, I want to check my topics. You can see that Kafka topic 5 has already showed up here. That's because I didn't show you yet, but I actually already have UniLink enabled as well. So anything that I do on my Confluent cluster ends up over here. So let me go ahead and show you that. For UniLink here, I have what are data migrations and schema migrations. So this is the new feature that we're releasing today. For the schema migration, that's going to be very important. Here I'm moving the schemas over from the legacy cluster into this one. That's going to be very important because I want those schemas to be able to publish the data into Snowflake or S3 tables or Databricks Unity catalog in a way where I can actually get columns in my tables that match my schema. The data migration actually is going to do two things for me. It's going to move the data over, which we're going to head into Snowflake and look at the data shortly. But it also is going to move my offsets of my consumer groups. So when I'm ready to move my application over, I want to be able to stop the consumer on the source cluster and then start it up here, and it to pick up automatically where it left off. And then eventually we'll move the producer over as well. So as you can see here, I have the data starting to flow into that topic. Let me go back over there again. Into topic 5, you can see there's data over here. And this backend is registered to use Snowflake Open Catalog. So let me show you what that looks like in Snowflake. So Open Catalog, the UI looks like this. I haven't refreshed this page yet. So there's actually Kafka topic 5 already showed up. That was pretty quick. I thought I had to refresh the page for it to
I think we lost Dustin for a bit.
Yeah, I guess we lost that thing. The most exciting part. Just give that thing
A few seconds, yeah.
show up
a
there.
few seconds.
But Kafka is moved. There we go. Kundan, are you still there?
Yeah, we are here.
Yes.
Yeah.
You
lost
lost
me for 15 seconds. Yes.
Okay, where did you already see this page with Snowflake Open
Yeah, you
Catalog?
were mentioning that the topic already showed
Kafka
up.
5.
Yeah.
Perfect. You were smiling when I said it automatically showed up, and then you froze with a big smile. So I waited until your video started back up. So you didn't miss anything. Keep your video on so I can see as long as you keep moving. I know
Yes.
I'm probably okay. So here in Snowflake Open Catalog, Kafka topic 5 already showed up. But what's really important here is the schema automatically showed up too. This schema is actually the one from the legacy cluster that the migration also helped move. So that means when I look at this data inside of Snowflake, it's going to have nice, beautiful columns with all of the column headings already populated. So right now, Snowflake Open Catalog and the regular Snowflake UI, where you do all of your AI work, are actually two separate applications, sort of. So this is Snowflake Open Catalog. Let me go over to Snowflake, where I can actually then query the data. Let me find that one. Here it is. Okay. So to get that data into Snowflake, you have to go through a process of creating an external volume and a catalog integration, which I've already done. But what I still need to do is create an externally managed table. So we have a new topic here to show up, or that I need to show up here in my databases. So I'm going to just quickly create that managed table. And the warehouse is going to work on that, finished up. And then if I go ahead and query that table directly, let me go to the new topic. And I'm just sorting, descending by the publishing time. It says that I have a field here. That's my item. That was my string that I'm publishing. It says published to legacy Kafka. And then I'm up to value 290. Let me go head back into IntelliJ, and we can take a look at where we actually are in the publishing. So we're at about 360. So we're about a minute behind. So this is all tunable. There's actually multiple things going on here. If you remember, this is all being published on that legacy cluster. UniLink is moving the data over, and then we are taking that data and compacting it down into Parquet files and registering them in Snowflake Open Catalog periodically. So the rate at which we do that defines the size of the Parquet files, and we can tune that for your applications. But it's all happening automatically so that it's viewable in Snowflake. And remember, this is still your legacy application running over in the old cluster. So let me go ahead one more time and click the play button, and we should see that we have more registered data. So it's our cluster is automatically registering that. Another thing is, because this is in the Iceberg format and we're querying using SQL queries here at Snowflake, you can also do table counts. So you can actually check the amount of data that you have totally that has moved from your stream into this Iceberg table or Iceberg format. and readable as a table. So I can do a count here, and now I have 352 messages that are accessible in this table. So that kind of shows the Ursa cluster. I already had it spun up. This one was already configured to use Snowflake Open Catalog. But then there's another step here where we want to actually migrate the application. And that requires us to be able to migrate the offset of the consumer group as well. So again, we've already shown the schemas migrated because it's all these tables are showing it nicely. The data is migrated. We also now want to move the application as one final step. So if I go back into IntelliJ and I have my consumer here, and my consumer group was Kafka 5, I am going to stop this consumer, and I'm actually just going to terminate it. So you probably have a correct procedure to terminate your applications, and a shutdown procedure. So I can't guarantee that these last few acknowledgements, because I just absolutely terminated this, went through. But we should see that when I start up a consumer reading from my new cluster, we should be around 485 or 486, because we're actually doing a byte for byte transfer of the messages so that the offsets match on the new cluster as well. I just have to make sure I use the same consumer group. So I'm using Kafka 5 here. And then I've already set up a separate consumer, also using Kafka 5. So I'm going to go ahead and close out this consumer. This new consumer is pointing to my stream native Ursa cluster. So I'm going to go ahead and start that up. I didn't talk about what it would take to move an existing application over. Typically, let me just start this up, make sure I got everything right. Typically, you would need to move the endpoint, and then you have a username and a password for your API key. So with those few pieces of information, you can actually edit your existing application and then just shift it over to the new cluster. If I scroll up, you can see here it started at 485. I think that's 1 or 2 acts were lost just because I terminated the application without verifying that the final acts made it into my legacy cluster. But whatever was in the legacy cluster as the offset for that consumer group is what makes it over into the stream native Ursa cluster. So we're still publishing into the legacy cluster. The final goal then is to move the producer over as well. So I'm going to go ahead and stop the producer on the source cluster. So now technically everything is done with the source cluster. There's no more data to migrate, there's no more schema to migrate, and there's no more offsets to migrate. So we could technically turn off UniLink at this point as well as get rid of our old cluster as soon as we verify the producer works. So our last message here was 596. Just so that when I look at the final data in Snowflake, I'm going to have the new producer start at 597. I'm just going to manually change this in here. So that's your producer would know where to pick up from producing its data. So let me start up this producer. And if I've got the endpoints correct on this one as well, this consumer should automatically start to pick up consuming from that same topic. So we're at 597. And so at this point now we're publishing to stream native. We're also consuming from stream native Ursa clusters. So we've completed the migration. Now the beauty of this is the backend doesn't care about any of this because the streams are just there in their original Ursa format and then compacted down into Parquet files. Whether it was data that came over from UniLink or data published directly into this cluster after migrating your application, it doesn't matter. So both of those types of data, which are essentially the same, are going to look exactly the same in Snowflake. So as I'd mentioned, it takes about 30 to 60 seconds, the way the cluster is currently tuned, to compact down that data. So I'm going to head back over to Snowflake, and let's start to see if we can now view the new data that was published. Let me find that one. There it is. So we already had created the managed table for Kafka 5. So all I need to do is run the exact same query. And we can see that now we have the data that's published to stream native and the data that's published to Kafka. They look identical in Snowflake. So we could have moved a bunch of historical data over and then started publishing this cluster as well. And all of this data looks exactly the same to Snowflake. It's all accessible. And you can see here that there's a continuation of the values here because I had made sure that the producer picked off right where it left off between 596 and 597. That's all I have for the snowflake side. I just want to show real quick in the S3 table example. This is a feature we have been working on, and let me find that. So in S3 table buckets here, you can make a special type of S3 bucket called a table bucket. Let me refresh this. Actually, I don't have Kafka 5 because I haven't started publishing to that one. This is actually a completely separate cluster setup. So the last one I published to this was Kafka 4, and then it's viewable inside of something like Athena. So again, this is a completely separate setup, different cluster I'm publishing to. So if I go into Athena and then look at that topic, Kafka 4, the data is queryable just like it was for the open catalog example. So you would be able to see that data. If I did a cutover, you'd be able to see the data that was published on the old cluster into the new cluster. And then I don't have an example up right now, but I have I have some videos up on our Stream Native Academy YouTube channel. Same thing for Databricks Unity Catalog. All three of them work very similar. It's just a different way to configure that cluster inside of the Stream Native UI. So I hope that is a great demo for you guys for Ursa, which is GA, as you guys announced today. The 3 catalog types, demoing one of them in depth, one of them just showing you what it could look like, and then Databricks Unity Catalog's another option. And then UniLink for the schema migration, the data migration, and also if you actually want to move your application over to get the offset of your consumer group. So handing it back to Kundan.
Perfect. Thank you so much, Dustin. That was phenomenal. This was really helpful. So let me come back quickly and wrap this up. We're going to talk about here. So again, you saw the updates today. I think Ursa is GA. Ursa comes with native integration to Databricks Unity Catalog, Snowflake Open Catalog, and Amazon S3 tables. Take advantage of that. And then UniLink is public preview. So please log in and sign up for a trial and give that a spin. Okay, quickly, just 2 more updates before we wrap up. Data Streaming Summit, Virtual Summit is in May 29th. So the call for paper is open. So you can submit your sessions here. We will review them and then definitely get back to you. So please do that. That's one. I'll give you just 2 more seconds to take a screenshot of this in case if you want. And then there's Iceberg Summit coming up soon. We are participating in that as well. So if you're going to be at the event, please stop by and we can tell you more about our integrations with Iceberg. All right. So I know we're short on time. Sign up for a trial here. You can scan for the barcode. I'll just leave 2 seconds here in case if you want to do that. You can submit a request for a demo as well. All right, so that would be all for today. I know we wanted to cover some Q&A, but I think we're 3 minutes over. So thank you so much again for being a part of this session, and we look forward to bringing you more updates regularly like this. Thank you again.